Announce it, I don't know why. I feel like I need to announce it. You're now being recorded. Okay, so everybody knows to be on their best behavior or something, I don't know. Anyway, just weird. This is weird stuff that happens in Webster brain. All right, there's a question about the 4.4 or 4.6. That package of handouts that I either handed to you or it is in the D2L. It's due today, right? Okay. So let's take a look because I think it might have something on it that you're not supposed to be doing. Last page, she says. All right. So I think we did on the first page here, we did just barely enough construction with some compass that I think you can figure that out. And a couple of you have asked me private questions about them. So I'm hoping that the compass part is okay. So 4.6, 8, 9, and 10. Okay. Yes. So the very bottom, numbers 8, 9, and 10 say, use the figure at the right to write a paragraph proof for each statement. And then the very last one says write a paragraph proof. So we clearly haven't gotten into proofing yet. We're about to. But you don't have those skills yet, if that makes sense. You will in a couple of weeks. You'll totally be able to do this for the test that's like the week of October 5th. But right now you don't have them. So you cannot do 8, 9, and 10, or you can give it a try and see if you can. I'll do it for extra credit. Question? What?
I already did 8, 9, 10.
You already did 8, 9, 10. That's okay. I'll use them for extra credit. So if you're like, oh, I struggled with that, then it won't be in vain. You'll get some extra credit points. That's what I'll do with that. So just so that I remember as I'm grading, make myself a little note. I didn't realize there was proofing questions on this particular homework, so thank you for pointing that out to me. This is the page 4.6 that's due today. So you can either just skip those 3, or if you want to try them, go for it. Now, if you're trying them, a paragraph proof means just write me sentences. That's all that really means. So you can, and we'll go through some of that stuff. We've been working through some of that stuff, like how do you know that these two are congruent and stuff like that. We just haven't put it all together into a proof yet. Okay, so yeah, let's do that. And I'm sorry if you worked extra, but it'll pay off for you. You will be like the proofing king. It'll be awesome. All right, so this guy is due today. Is there anything else due today? Did y'all have a quiz due today? Parallel lines is due today. The quiz on parallel or on triangles is due Thursday. So don't forget that those are out there. There's a homework from the book due on Thursday. It's pages, what, 57 and 62 or something like that? 59. All right, so let me see if I can write all this down so everybody's got it. Packet 4.4 through 4.6. And parallel lines quiz. These are due today by midnight, and then the triangle quiz. Oops. And page 51.
57. Numbers 3, 6, 9, 12.
15. Oh, nope, sorry. 15 through 24 all, right?
And then page 57, 11, and 16.
Just those two. And these guys are due on Thursday.
And you also have to read pages 28 through 73 before the first test.
Yes, there's also some reading out there, and actually I expanded on that in the D2L, so let me give you all of it that I think I put in D2L, just so that everybody's on the same page. page 28 through 73. That's what I mentioned the other day. 96 through 98, that's just 2 little pages. And 114 through 134. And I think I put up 144 through 165. I think that's what I put online. So that's kind of like everything that we're doing right now. So that gets you even more. So you don't have to read every little bit of that, of course, but if you're struggling on something like, say, quadrilaterals or this or that, then go into those sections and really read it and see if it makes more sense reading it from the book than from me, or put your notes with the book and see if that helps you out, that kind of thing. As many resources as you've got, you should try to use them. So that's all the homework that's out there right now, I'm pretty sure. Okay. All right. Yay. Good deal. Then we are supposed to talk about Geogebra today, right? I mentioned that. Why are you not closing? I don't understand why it's not closing. This is the problem. And I played with it at home to make sure that I could zoom and share my Geogebra, and it did at home. So let's keep our fingers crossed that it will do it here. If it doesn't, then we'll punt. Maybe I'll make a little video or something of it from home if I must. But I'd rather do it live and in person with you guys so you can all see. Google, not Googling. Google. Okay. I should have already had this up, but I was distracted by somebody in my office. Sorry, guys. What's wrong with you, Google? So slow. Oh. Let me share my screen. It's not even coming up because the Chrome's not up yet. So I lied. I'm just going to let Google try to load. It is really spinning. And probably whenever it comes up, it will like grab my attention and tell me that Google Chrome has loaded. And then I will, I'm going to keep it halfway. Doesn't help you guys any. It's finally trying to respond. There we go. Probably opened Google 5 times. All right, so Zoom quit unexpectedly. Go away. Zoom's not quit. I see it right here. All right, now let me see if I can share the screen. I'm sorry, guys. Technical difficulties. Share. All right. There.
I think it's sharing the other one.
Is it sharing the other one? Are you kidding me? This one? Let's kill one of them. All right, can you guys see a screen that says Google?
Yes.
All right, thank you. Okay, we're gonna just Google Geogebra. Pull it up. It's this guy right here, Geogebra Free Math Apps, used by over 100 million people. Woo. And once you have created your own account, you'll be able to sign in. No, I don't want to sign in. Oh man, why is it pulling up her information? What is my information? That's the problem. Should be able to log in. That's not right. Dang it, I should have done this first. think I think it made me use a special character, and that's going to be a problem. Come on, there we go. Okay, so you should be able to sign in. Such greatness. No, I don't want you to remember my password. Oh, wait. All right, and you'll have your own account. The reason you want an account is so that you can save files, okay? So you'll save files, it'll go into your account. As you create one, I left them on the printer, of course. As I put it into D2L though, so you go look at it. As you create an account or create a file and make different things, do different things, you'll want to be able to save it and then embed it and send me a link. That's what you're gonna wanna do with it. So for instance, there's all these different things in here you can do. I just picked geometry. Right there in the center, one of the options was geometry. And then you've got two different things that happen over here. One, this first thing, it's like just shows you the algebra that lines up with the geometry that you're gonna do. We don't really care about that so much right now. What we're after is the geometry. This little cursor button, it allows you to pick things and like use it like a cursor, like your mouse, and move things around, okay? I can draw a point. This one is actually nicer than what Geometry Sketchpad is, because as I put points out there, can everybody see the A, the B, and the C that I put out there? I'm just assuming that my Zoom people are okay unless one of you yells that there's a problem. So I put the A, the B, the C out there. This one's actually really nice because it goes ahead and labels them for you. Geometry Sketchpad would just put a point out there and it wouldn't label them. So you gotta make sure that it's got these tools. These up here are just considered like drawing tools. Like literally you're just drawing something. Like if I want to draw a line segment, I can just, where do I want to put my segment? Let me put it there, okay? And just put it on there. Same with the line, the difference being that a line goes on forever, right? So it's going to go off your page. So probably, unless there's a reason to do a line, you're probably not going to want to do the line because it goes like that and it takes up a lot of space, right? Now the thing about these is, let me go back to my little cursor tool here. Like I've got this G on here, I can tilt it, okay? I put the D point there, I can move him. That's what the little cursor guy does for me. I put the A in there, but I don't want him there anymore. Look, you guys make me some space so I can see stuff down there. So you'll have to play with it a little bit, and that's the whole point of the first lab that I'm going to give you guys today, is that you can go in and you can play with the software, you can learn a little bit about it and see what's going on, and it's relatively low stakes, okay? Two more drawing tools. Here's the polygon, okay? The idea about, and look at here, down here at the bottom left-hand corner, when I click on it, you see it pops up directions. So if you're not sure how to draw a polygon, it will give you a little bit of guidance there, not a lot, but a little bit. Select all your vertices, then the first one again. So here I'm going to draw a polygon. Oops. Okay. I can make a triangle right now if I want to by going back to H, but if I don't want to go back to H yet, I can make a quadrilateral. I can make a pentagon. It's just going to keep on going until I close the loop, so to speak, by going back to the original vertex. That's what it means by that. These are just drawing tools. One more. Here's the circle. You just pick a spot. That's your center of your circle. And then you expand it out and draw the circle. Okay, so these are just drawing tools. They are not construction tools. Okay, and that's the difference. I didn't do any kind of construction. By construct, you know, we mean you can use a circle created by a compass, or you can use a straight edge, and that's it, right? Okay, so I wasn't doing any of that kind of stuff here. The more button, that's where they're hiding everything. You see it over here on the left-hand side? Those were just drawing tools. here's the more. Look at that. All that stuff comes up. There's a lot. Okay, lots of stuff over there that's hiding. Okay, I can edit, I can label, I can hide labels, I can get rid of something. Like say that I just hate this line segment here, just dump it. Okay, if I hate this point, I can dump that point and get rid of whatever I want to get rid of. I don't like that line, go away. Okay, so that's the delete button, the erase button, if you will. The construction is really a good one. And these are the things that you're going to be doing on the first lab. I think it says, create a triangle in 3 different ways. Okay, 1, draw 2 dots and make a segment and then connect them by drawing the segment in. 2, create a segment and then connect the segment to the next segment and so on and so on. Or 3, use a polygon tool. Okay. So those are just drawing things. But then I want to know, okay, can you, let's say, let me get a segment back in here. I deleted my segment. Can you find the midpoint of this segment DE? Okay. Well, when, oh, I don't want to point. Delete R, go away. Okay, so if I want to find the midpoint of that, what you can't do is you can't come in here and just put a point right here and say that's your midpoint. Okay, you can't do that because that's not constructing the midpoint. So I cannot come in here and just go, oh, that looks about, oh, I just deleted it. Right. I cannot, so did you notice that it keeps on doing whatever the last thing was I told it to do? Okay, because I was on delete and then I hit the segment. I didn't mean to delete it, but it did it anyway. So yeah, you can undo. There's this little arrow here to undo. So you can use that feature if you want to. But I can't go, oh, look, that's the midpoint. Oop, that's the midpoint. We're done. Okay, there's a couple of reasons why. You see this measure thing here. I'm going to measure the distance between D and E. Oh. It's telling me that the distance there is 5.9. I don't know, those are probably centimeters would be my guess. Okay. Did you see I just moved it out of my way because it always puts it right in your way, by the way. So I had to move it out of the way. And then I'm going to measure the distance from D to R. And again, it puts it in my way, so I have to move it. Go get your cursor and move it, okay? First of all, that's not even half, right? Oh, you can change the decimals if you want to. You can go in and I think it's the right click and yeah, here's stuff, here's my setting. And maybe I want it, I think my zoom's in on. Let's go settings over here. 1 decimal place is what the setting is now. Maybe I want 3 decimal places. Okay, it just changed all my decimal places. So that lets you see it a little bit better. Let me get rid of that. My zoom went away. Sorry, guys. But clearly that's not the halfway mark, even though I tried to make it look like the halfway mark. Okay, so the measurements will tell on you, first of all. And the second thing is, this is how I'm going to check it, or how my GA is going to check it. They're going to come in here and they're going to grab this endpoint and they're going to pull it and move it around. And guess what? See how those measurements change? Okay. It's still not half. Do you see that? So we're going to have a problem because it's not going to be exactly half. If it was half, this is how you would do it correctly. So I have this segment here. I'm going to create or construct the midpoint for this segment. Oh, it still called it R. Let's measure now and see what's going on. So now I go back to measure. I find the distance, measure DE. It's slightly different, I hope. I'm going to get you out of my way. And then I'm going to go measure the distance from DR. And hopefully that is half. Let's see if I can, here. 5 centimeters, whatever it is, it's not exact. think if I was only at 1 decimal, it would be. Okay. So I either need to probably make that more decimals or less decimals. But now I see, okay, that's really sitting there in the middle, and I can see it's growing with the other one. It looks 5, half of 5 is 2.5. That's pretty close. So I'm pretty happy with that. And again, as I move it, the measurements go with it, right? So we can see 11. 11 would be 5.5, so it's really, really close. It's just not exact. Maybe it's too exact should be the problem. I can't get it exactly on the 11. Okay, but that's the idea there. There are other things going on in here. What I want you to focus on right now, you're going to be constructing circles, drawing circles. There are several different ways for you to draw a circle. You can either put the point in the middle and then expand out the radius, or like I can use, let me move this guy. I can use this line segment, say, as the circle with the center. Here's my center. Boom. Did you see it kind of snap to the end of the segment? So now I can say, hey, that guy's my radius. So if I grab this, stop it. Move. If I grab this and I move it, see the line segment changes and the circle moves with it. Right? Because the radius is growing on that circle, right? So there we go. So there's different tools in here. You're going to, the first thing is play with it. See if you can make different segments. See if you can make different rays. I think that one of your assignments is draw an angle and then make the bisector. Okay, so draw the angle, make the bisector, and then measure them, and measure the original angle, measure the half angle. Make sure that they're about half. Making a circle in 2 or 3 different ways, making a triangle in 2 or 3 different ways, just to get you familiar with it, okay? When you're finished, if you love this thing, then you're gonna save it. That's not it. No, I certainly didn't want that. Hang on. I swear I did this the other day. Ah, there it is. It's this little angly guy, okay, at the top. Save it, give it a name, call it Lab 1 or Intro Lab or something like that. And then you're gonna wanna share that with me. Oops, stop it. You're gonna wanna share that with me. Oops. There you go. So whenever I click on that angle now, look, I can export it. You could print it. I don't want any prints. What I want you to do is to embed it. So you click on embed there, and then you'll create a Word document, for instance. That's going to take forever for this thing to load. And you'll paste and just give me that link. Does that make sense? So make a Word document, paste the embedded link into it, and then send me that. You can make it into a PDF from Word if you want to, that kind of thing. But
Is there a difference between embedding and just copying the link? Because it gives the option for both.
you could copy the link, that's fine. Okay, good. All right. Whichever is easier for you. Go away, little chat box. Why are you giving me problems today? Man, okay. Stop sharing. It's like it kicked me out or something. There. Oh my gosh, this is crazy today. We usually do better than this, guys. I'm sorry. Okay. Chat. There we go.
Are the instructions for that intro lab in D2L already?
Yes, I already put it up there right before I came to class. Did all you Zoom people see all that GeoGebra stuff? Now I'm a little nervous because it like muted me all of a sudden.
I don't think I'm using the right Geogebra. I have the application for it.
There is a spot where you can download the app, like onto your device and stuff. As long as it's Geogebra, you should be okay. I don't know how that's different from the website, so, but it should, I would think, have all the same functionality.
What is the due date for that?
What is the what? Oh, due date. It'll be 2 weeks from now. Creating my account now, she says. Yes, yes. Okay. Good, good. All right. So, intro, Geogebra. Oh, I can't spell. Lab. Nice thing about this is it's free. Yay. Maybe the bad thing is it's internet based, so who knows how long it's going to be there, but it's pretty stable. It's been around for a while, so hopefully everybody's good. What did I just tell you? 2 weeks, which is the 29th. Okay, thanks. Yeah, that way it gives you a little bit of time to play with it. I don't think it'll take you that long to do the intro. I just want you to be able to get an account, get into it, get going, and all that good stuff. All right. Whew. Anytime I do something different on this thing, it starts giving me issues. So hopefully that works. No problem, Matt.
Where's that page down?
Move the page. Okay, so 2 weeks on that lab. All I did on week 4 is just load this up there. There's no directions or anything, so I'll flesh that out so that everybody knows what's going on, and we'll go from there. Yay. Wasn't that fun? Did you get an account already? You're already in? I don't think it'll be a difficult lab. I just want you to have time to play with it. All right. Okay then. So there's your GeoGebra assignment. Yay! And once we do that intro lab, then I'll be like, cool, they can do all this stuff. And next is parallel lines and all that. So we'll kind of catch up on some of the topics that we've already covered. We've already been in parallel lines. We've already done triangles. We're into quadrilaterals now. And you'll see, what I hope you see from the online software is it's so much more accurate than we are, and it's so much easier than constructing by hand, okay? So anytime you can make the computer construct for you, it's gonna be a lot easier and hopefully faster than doing it on your own. All right, let's get moving. We had just started into basically what I consider chapter 5, which is all the polygon stuff. They kind of say triangles, boom, here's all the triangle properties. And then they take the triangles and they help them to build all the other polygons, okay? So 2 triangles put together makes it into a quadrilateral, that kind of stuff. So we had just done, I don't even have one. We had just done the page with all the quadrilateral properties on it, right? Somewhere. Did I hide it from myself? And I was like, oh, we're gonna work on, there it is. We're gonna work on these, right? That's what we had started doing. So here's that page. If you haven't gotten it off of D2L yet, get it off of D2L. There we go. And the first sections are gonna be about kites and trapezoids. I think they just want to get those out of the way and then focus on parallelograms. So I think I had even mentioned, well, are those diagonals perpendicular or are they not, right? So we're going to look at that today. All right. Yay, quadrilaterals. So before we get too far into there, there are 2 little properties that we want to get out of the way about polygons in general. exterior angles. That's the first one that we want to talk about. Okay, so what we're going to do is, I need a piece of patty paper. Oh, that's where I have some. Will be. And I'm just going to draw for you some polygons. Let's do first a triangle because we're really familiar with those now. And then I'll do some other kind of polygon. And again, I'm just drawing them. I'm not constructing them in any interesting way or anything like that. So I want to talk about the exterior angles. Now we already know something about our exterior angles. Let me call this guy, I'm going to label him inside A, B, and C. We know that, for instance, if I do the exterior angle on A, I'm not doing the 180 degree side, right? I'm doing the side that adds to A to make 180 degrees, okay? And it doesn't matter if I go this way or if I go that way because those are vertical angles, right? So whichever way you want to create your exterior angle is fine. All right. And so I'm going to do that on all three, A, B, and C. And we have already an exterior angle property. Y'all remember what that was? For instance, what do I know about this exterior angle here on C?
It's A plus B.
It is A plus B. Everybody remember that was in one of your homeworks. I think one of the ones that's due like today, right? Okay. So this exterior guy on angle C is equal to A plus B. All right. So that we know. What I'd like to do though is figure out how big these exterior angles are. Okay. So let's do a for instance. I'll come back to my patty paper. What if we had a N, I should say. Let's call him an equilateral triangle, even if he's not quite. He's definitely isosceles. Let's make him isosceles. Let's say this is 80 degrees and this is 80 degrees. Let's call this guy D, E, F. What's that, 20 degrees up there? That's not true, but let's just say it is. All right, it doesn't matter. And y'all talk to me about the exterior angles. What would they be? Even though they don't match my picture. This adds up to 180, right? So even though my picture stinks, we're not violating any geometry rules. So this guy out here would have to be what? 100 degrees. And this guy out here is 100 degrees. And how big does this guy have to be? 160 degrees. So whenever I look at that, even though my picture stinks, I can tell that the sum of the exterior angles is what? 100 plus 100 plus 160 is 360 degrees. Everybody agree? All right, so as I go through, I want to talk a tiny bit about that as I look at my patty paper triangle. All right. 360 degrees is twice 180. Everybody agree? Do you know any kind of something about 360 degrees? It's a circle. Very good. Does everybody agree? 360 degrees makes a circle. So what I'm doing is I've got my exterior angle guys here. I am going to pull off each of my angles, including the exterior guy. And I'm going to see, before we put together our interior angles and try to make a straight line, right? That was 180 degrees. But if this really works, then what we're saying is that those exterior angles will add up to be a circle, right? Because they're 360 degrees. So let's see if I can make that work. Here's my angle A's exterior angle. I'm going to overlap with him and put my angle B's or C's exterior angle. What you need to do is make sure the vertices match and that one of the legs is the same, okay? And then I need to do, so here's this exterior, the angle B's exterior angle, and look, sure enough, here was the beginning of the angle A exterior angle, right? He was the empty guy. Here was the angle C exterior angle, and here's the angle B exterior angle. And sure enough, that B fits perfectly so that the exterior angle finishes where the A angle ended, right? So it started here and I went around, around, and around, and it went all the way around in a circle, okay? So we see, huh, that's kind of cool. That makes 360 degrees. And you might think to yourself, well, self, the interior angles of a square was bigger, right? And the interior angles of a pentagon was bigger. So the exterior angles are going to grow bigger. And if you thought that to yourself, you would be wrong. And this is a weirdness. So let's talk about it. Let's do an easy one. Let's do a rectangle. Okay. Rectangle we know has two parallel sides, two sets of parallel sides, and 90-degree angles, right? Okay. Well, think about it with me. If this is a 90-degree angle, then what's his exterior angle? Let's call him G, H, I, and J. Okay. It's what? Summer said 90 degrees also, right? It's got to be 90 degrees right here. So his exterior angle is 90. Well, if this guy's 90, then that guy's is 90, and that guy's is 90, and that guy's is 90. So 90 times 4 is still 360. Oh, and that's only because he's a square or a rectangle. He's special. Actually, it's not. Okay, so the really neat thing is it doesn't matter how many sides I give this polygon. I'm going to give him 5 if I can possibly draw me one that has 5 sides. Because, and this is the cool part, whenever we go with the exterior angles, I didn't draw my exterior angles, so let me do that. Let me draw some exterior angles. I'm going to draw them all in the same direction. So I'm drawing outside and to the right, the exterior angle. Outside and to the right, outside and to the right. It doesn't matter, right? And this one up, outside and to the right. It doesn't matter which direction we drew it. We already determined that, right? So here's the thought that's going on with these exterior angles. I've got really long sides here. If I didn't have really long sides, I could squish it in a little bit, right? And this would get closer and closer and closer to one another, like this. Okay, try that. I made him a big pentagon. He didn't have to be a big pentagon, right? Oops, I need to line you up. I'm gonna get too many pieces of patty paper going. He could be a smaller pentagon. Pentagon. Right? Like that. Okay. Does that change the fact that his interior angles are the same? It doesn't change his exterior angles, right? And so if I just keep on pushing them in, push these guys in, push them in, push them in, push them in, eventually what's going to happen is that pentagon is going to be so small these vertices are going to be on top of each other. And then what do I have? A point. And then what do I have around it? A circle. Okay, so we just keep on shoving them in basically until it's just a point. If you can see that in my terrible picture. It's just a point, and basically I have a pinwheel going around it, and now it's a circle around it. So it doesn't matter what shape I used. It's kind of interesting. So there's the exterior angles. Exterior angles of any polygon add up to 360 degrees. There's that property. And it doesn't matter how many sides it has. It's actually kind of a cool property. Different, because I would have thought, man, it's always going to be changing on me, but it doesn't, because they always just push together into a point, and then I've got a circle all the way around it. That's exactly what's going on there. Yay, cool beans. All right, so that is the beginnings of chapter 5. We've already done the interior angle, so I'm not going to stress out about that. Which brings me to kites and trapezoids, which is where we're headed today, okay? So let's start out with some of the kite properties and talk about what the heck is going on. And we're going to go ahead and start trying to show some stuff. I won't say prove necessarily, but we're working toward proofs, right? So let's go. A kite. Remember that guy from the other day? He had a definition. It was that he had two sets of congruent sides, congruent consecutive sides, right? Okay. So as I look at that, I say, oh, we need to name this guy. What are we up to? KLMN? KLMN. Okay, I'm going to name him, and we said, for instance, LM is the same as NM. Those are congruent. And KL is congruent to NL. Okay? And we said to ourselves, oh my gosh, it looks like the diagonals that are going through here meet in 90-degree angles. We feel like those were perpendicular. That's what we were saying at the end of class on last week. So I'd like to kind of sort of see if we can do some properties. See if we can figure out some stuff that's going on here. As I look at them, I say, okay, if LM and MN are congruent to each other, is there anything else in that picture that tells me that I can just see looking at it straight up? Any properties? Look at both the big picture, the big triangles, and the little triangles. There's lots of triangles going on here. That's probably the problem, right? Let's look at these two triangles. I'd like to look at triangle KLM. KLM. I'm going to separate them just slightly so we can see that there's two triangles there. And I'd like to look at triangle KMN. And let me go ahead and mark these guys. And then we'll talk about it. Okay, so those are two of the larger triangles is what I'm saying. There's big triangles, there's little triangles, there's all kinds of pieces going in there. So can we compare those two triangles to each other? it would be lovely if we could use side, side, side here. Does everybody agree? We already have two sets of congruent sides, right? That's in the definition. So where are you seeing the third side? Oh, KM is congruent to MK. Does everybody agree? Okay, so there's my third side. So what we know is these two big triangles are congruent to each other. Okay, so this is congruent to that, this is congruent to that. Looking at that, there's one little property that comes right out that just jumps out at me, which is, okay, well then, if these whole triangles are congruent to each other, then this angle L is congruent to what? Angle N. Does everybody agree? What argument would I use for that? CP, CTC. Corresponding parts of congruent triangles are congruent, right? Remember that? And I told you that guy's going to be with us the whole semester. We're just going to love him because he just keeps on coming back. Okay, CP, CTC. So angle L is congruent to angle N. So the property says, okay, let me just throw this out here. In a kite, these two, the guys at the end of the big diagonal, those are called your vertex angles, okay, your vertices. And these two on the sides, those are your non-vertex angles, okay? So what we're seeing is that the non-vertex angles are congruent. And I'm using my little congruency sign there. Does everybody agree with that statement? Okay, so that's one of the properties we just saw. Boom, done. Okay. I see another one in there. Let's get it while we're sitting here. Okay. If, again, this is a congruent triangle to this one, then angle M down here has 2 marks on it, and who's he congruent to? The other angle M, right? Okay, so those have to be congruent. And while I'm at it, let me go ahead and say the third angle has to be congruent too, right? Because congruent part or corresponding parts of congruent triangles are congruent. So all 3 of those angles are congruent to each other. Well, if this angle here is congruent to this angle here, then what does that mean that this diagonal is doing? Bisecting. Does everybody agree? And same thing up here, the 3 and the 3, that angle there is congruent to that angle there. Then what that diagonal is doing is it's bisecting my vertex angles. Is that okay? Yes.
So the line that's going horizontally is cutting LN in half. On the picture to the right, left.
Oh, hold that thought. Just a second. Okay, so my vertex angles, yes, that can be our next property, are bisected by the diagonal. Everybody see that? And again, I'm talking about just some generic kite here, right? I don't have any measurements on it. So these are proofs. Whenever you talk in a generic way, and this would work for anything, that's a proof. Okay, so I've got that going on. Okay, and then I heard, well then, what we think is that LN has been bisected also. That's what Ashley's telling me, right? Okay, so how do I know that? I don't see it. How did you get there?
Okay, if you call the little cross that's in the middle, like what's its main MO? Yeah. Right in the middle, those 2 smaller triangles would be congruent to each other.
These
So
two?
I'm guessing the sides would also work, but I don't know if that's like a real proof or not.
Okay, let's look at it. You're on it. I like it. Okay, so she's saying where the diagonals meet here in the middle, okay, that she thinks this, this little triangle, okay. Let me give him a name. Let's call this intersection point here O, okay, so we can talk about him. She thinks, let me redraw this, KLO. Sometimes it just helps for you to see it as a bigger picture, I think. So we've got this, that's got 3, KLO and the triangle that's right underneath it, those two little bitty triangles. She thinks those are congruent. And we've got that, okay? Now we've got to prove it. That's KO right there, right? And we're going to use the same thought that you guys used on the other one. Isn't KO congruent to OK? That's the same segment, right? So that third side has to be congruent to each other, okay? Just like it worked on the last one, it works here. And now I don't have side, side, side though. Now what do I have? Side, angle, side, okay? So that's why we went through, this was side, side, side up here. That's why we went through all those triangle congruencies first, was so that we could see, oh, that's the same thing, right? So she's got it. She's saying these two little triangles, side, angle, side, those are congruent to each other. And because of corresponding parts of congruent triangles, I know that LO is congruent to ON, right? Because those are the corresponding parts. And so now she's saying, look, that smaller diagonal was also bisected. Is that okay? Yep, that's absolutely one of our points. Okay, so the diagonal on the non-vertex angles is bisected by the other diagonal. Absolutely. You got it. Nice. See that? And then this picture up here just starts getting really crowded. That's why sometimes I redraw them. I think that I'm up to 4 marks there, so those are congruent. So we see, okay, that smaller diagonal is bisected. What about the long diagonal? Is he bisected? No, he's not, right? So it really matters that we know which one's the vertex diagonal and which one's the non-vertex diagonal, because the vertex diagonal is bisecting these angles, but the non-vertex diagonal is being bisected, okay? So he is in half, okay? What else y'all got for me? We're almost there. We almost have all of our properties. In fact, there's only one more. It's the one I started out with. Do we think that these diagonals are perpendicular? That's the question. When they intersect in the center, is that 90 degrees?
Yes.
We think yes. We feel it. We feel it in our blood. It is a yes. Anybody got an idea for us? I feel it is too. Yes, ma'am.
The two angles next to O for the L and M side, they have to be the same because of the concurrent sides.
Which we're just
So like the LOM and NOL, those have to be the same measurement because of LM being congruent to NM.
okay. We think that this angle here is congruent to this angle here?
Yes.
Okay, why do you think that?
Because of the, because LM is congruent to NM.
Okay, so that gives me,
They're corresponding, like you said.
oh, we need to look at this other set of triangles, don't we? Let me redraw that. So she's saying here, this is the third set of, hopefully, we hope, congruent triangles, right? We think they are. So we're going to prove it. Okay, she's absolutely correct. So she's got LOM here, and the other triangle is MON here. This one is congruent to that one. We know this one is congruent to that one. And we know this angle down here, and we know those two are congruent. The problem is right now I've got angle side side or side side angle, so we know we can't use that one. But what? There's something we can use. We can do side 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 again, can't we? Does everybody agree OM is congruent to MO? Okay, so these I'm just going to do a little lightning bolt. I'm out of congruency marks. Okay, those are congruent to each other. So these triangles are, we've got a side, side, side. Does everybody see that? Okay. So if we've got a side, 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 and these are congruent, then the corresponding parts have to match. The corresponding parts here, we've got the little guys here. Let me put a lightning bolt in this one and a lightning bolt in this one. Okay, those are the ones that match, the L and the N. The O is itself, congruent to itself, right? So, and what we've got is two congruent angles. They are congruent, but they make a straight line. Do you see that? So if I have 180 degrees and they equal each other, then that means 90 and 90. Does that make sense? There's actually some right angle supplementary something postulate that's out there that says if you have two angles that are congruent to each other and they make a straight line, then they must be 90 degrees. Okay, so it's actually like probably in your list somewhere. Somebody says angle KOL and LOM are supplementary because the bisector is a line. Absolutely, Mary, you're right. So we already had it from the other side. We just didn't quite look at it right. Same thing going on over here. This angle, KON, she said, and KOL, those, let me do a W on them or something. Those are definitely congruent to each other. And the same thing we just said, because they make a straight line and we're bisecting it, they had to be 90 degrees, right? Okay. So in fact, this diagonal right here doesn't just bisect this, but it's actually a perpendicular bisector, right? So it makes them into 90 degrees. So yay, the two diagonals are perpendicular to each other, which is what we set out to prove. Absolutely. Good job, guys. It's a group effort. I love it. That is our last property for kites. Very nice. Two diagonals are perpendicular to each other. And so now we have all these pieces inside of this kite. Let me pull this picture down a little bit again. We have all these pieces inside of this kite, and we know that they're all congruent to each other, right? The little piece is a little piece. Those are all congruent. We have these as all four 90-degree angles. Makes a 360 degree around it. All kinds of pretty stuff going on in there, guys. Very nice job. Okay. So do you see how you took one step at a time and you said, let's prove this. Now let's show this. Now let's show this. That's the basics of what a proof would be. In this book, they talk about three basic different kinds of proofs. The first one that they use is the paragraph proof, which you saw in homework, right? Which is why I was like, oh man, I didn't get that far. So the paragraph proof would literally be if somebody was writing down exactly what we said as we went across. Okay, well, we know LM is congruent to NM, so therefore, you know, blah, 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 blah. I know. It's a little tedious. Actually, give me that look. It's a little tedious, but it's not terrible, and we can do it, which is good. Yeah, there you go. All you never wanted to know about kites. But now the cool thing is we have these four properties about kites, and later whenever we see something in a homework assignment or something says, hey, what about this? We'll go, oh, we can do that, no problem. Okay, and we'll just figure it out and go from there. It'll be awesome. Okay, there are my kite properties. Trapezoids. That's the other one. All right, so let's remember trapezoids. Trapezoids have one pair of parallel sides, right? And they can come in all different kinds of stuff. They can come isosceles, they can come right. They've got different properties you can put in there. I'm just going to call this guy Trap, T-R-A-P, and we'll talk about him a little bit. Everybody all right? All right. There's 3 basic properties we want to get about trapezoids. I think we've got time. We'll be okay. All right. What I'd like to do is I would like to extend out my parallel lines. Everybody knows that whenever I'm looking at, for instance, a polygon like this, a trapezoid like that, I'm just doing a little segment, but we know that they actually lie on a longer line if I need that bigger line, all right? We just don't normally draw them all the way out. We're just normally putting between 2 endpoints a little segment, okay? But if I extend those, then suddenly, here, let me extend these lines too, TA and RP. Suddenly, my trapezoid looks like it's right in the middle of the parallel line stuff that we did the first week of school, right? So then, automatically in my brain, starts popping up all those parallel line properties that we already have, right? Okay, so if we can use that in some way, it would be helpful. So let's, for instance, see, okay, what do we have going on here? I'm just going to pick on the transversal TA first, if that's okay with everybody. And I'm going to imagine that on that transversal I have angle 1, 2, 3, 4, 5, 6, 7, 8, just like we always would have whenever we were doing those parallel lines things. So for instance, right here, what would normally be angle 4, the inside of the T, angle T, that guy is congruent to where? The outside here, and the upper guy there, and the outside there. Does everybody agree? Those 4 are congruent. Okay. Those would be the different properties: alternate interior, alternate exterior, vertical angles. Yeah, all that stuff. It all adds up. Okay. So what do I know about the other 4 angles that are on that line? They're the little acute angles, right? Yeah, they're congruent to each other. And they're a little less than 90-degree guys, right? Okay. So this is a little bit for us to think about. Now on the other side, let me go ahead and finish this out. On the other side, I still have the same properties going on, but we can't say that we know that these angles are equal to these angles because I don't know that, right? I didn't give you any sign that they really are isosceles. We would have to show that. So instead of like marking congruencies with these, I'm going to call this guy 3. The little guy's 3, and I'm going to call the big ones 4. Is that okay? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. It doesn't matter because we're just going to use the same thing on the left that we use on the right, the same concept. So here's what I want to talk about. Right here, between the 1 hash mark guy and the 2 hash mark guy, what's going on there? They're a linear pair. They make 180 degrees. Everybody agree? Okay. Now think about it this way. Instead, right here on the inside of the trapezoid, I have this guy and this guy. But this big guy, we know is congruent to that guy. Does everybody agree with that? So what do we think about this angle? Let me mark it, 1 and angle 2. What do we think about angle 1 and angle 2? They're supplementary. Does that make sense? Okay. So here's what we have to say. We know that, let me go ahead and also label this guy angle 3 just so that I can be lazy. Okay. We know that angle 3 plus angle 2, those measures, I should put the little M out in front of them. Measure of angle 1 or 3 plus the measure of angle 2 equals 180 degrees because they make a straight line. Is everybody okay with that statement? Okay. We also know angle 1 is congruent to angle 3 because they are alternate interior angles. Everybody agree with that? Angle 1 and angle 3. Okay, they're alternate interior angles, so they have to be congruent. Okay, what does congruent mean? Here's it's a little step and people just go, well, duh. But if you miss this step, you'll miss a point or something on a proof. We know that they're congruent. This mark right here means congruent. That isn't measures equal. We're talking about measures. So what does congruent mean? Why are we always marking things congruent? They have the same measure. That's exactly what they mean. And often we use those interchangeably, okay? But we can only talk about measurements whenever we're talking numbers. Does that make sense? Okay. Otherwise, if we're just talking generic angles, they're just congruent. Okay, I think I've mentioned that once before. So by definition of congruent, the measure of angle 1 equals the measure of angle 3. Everybody agree? They're the same. That's all we're saying. Okay, we have to throw that little, congruent means measures are equal. We have to throw that in there if we want to switch, which we want to switch, right? We want to go to measures because that's what we're working on. So now what would we like to do? We really want to do, we don't care about angle 3 plus angle 2. We care about angle 1 plus angle 2, right? Isn't that what we were after? Angle 1 and angle 2, we want those to be 180 degrees. Okay, so we'd like to what? What is that called in math whenever we have some angle A and we know that it's congruent to angle B and we'd like to put that in its place? I don't want to talk about angle A, now I want to talk about angle B. Yeah, we want to substitute. Does everybody agree? Let's substitute. Yeah. What property is that called? Substitution property of equalities. Okay, by the substitution property of equalities, it's equalities because I've got an equal sign, right? Look here. Measure of angle 1 plus measure of angle 1 plus measure of angle 2 equals 180 degrees. That's what we're after, right? And we literally just come up here and where I see the angle 3, measure of angle 3, I just pop in measure of angle 1. I substitute, right? Look, we just wrote our first paragraph proof. Therefore, consecutive angles in a trapezoid, no space there, between parallel lines, add up to 180 degrees, or you could say they're supplementary. Right, if you'd rather use that word, that's fine. However you want to say that. So we use this picture, but yet we see it going on. By the way, I didn't do the other side, right? I showed you that the logic is the same. I only did the left-hand side, but we would need to do the right-hand side to show it worked on both sides because we're generic over here, right? But it's the same thing, right? This is the same as that. These two add up, so therefore these two will add up to 180 degrees. So it's the same thing on both sides of the trap. I cheated. I skipped the right-hand side. So really, you should make me prove the right-hand side before you let me say my therefore. But let me off the hook now because I'm out of time, right? Okay. But does that make sense to everybody? Do you see how that property comes in? So we're going to finish out these. There's 2 more properties of trapezoids whenever we come back on Thursday. And we'll see how all that goes. Let me, I'm out of time. I got 30 seconds. Okay, let me give you a homework real quick. I know, stinker. That's not very nice of her. You have, let's see. Did I give you page 62 yet? Okay, page 62, 1 through 7 plus 12. And 66, 1 through 8, plus 12 and 13. All right, and then we're not far enough in this section yet, so that's actually kind of good. These are things that we did last week, so you can finish out that homework, and then once we finish this that we're working on, I'll give you homework on this stuff. 1 week from today, today's the 15th, so 22nd? Yay. All right. There we go. People on the, I know who's here in Commerce, y'all can go on. People on Zoom, I've got Amberly. I want to call your name, you can take it off. I've got Garrett. I've got Jessica. I've got Mary. Somebody signed off before I wheeled it in. I've got Samantha and I've got Matt. Y'all have a great weekend or week. Yeah. Somebody signed out before I got them. All right, I'm stopping the recording. Yay.